Happy New Year, Algebra 2. This is my first video lesson of 2021. Cheers to hopefully a better year. Alright, we're going to get right into it because these two problems, I don't know, take a little while. This is my second time recording it because I talked too slow last time. So, and I'm rusty. Title of the notes, if you haven't already, for 1 day 2, all transformations. So let's start with that generalized equation. Very similar to all the other functions we've learned. So what algebra? Absolute value, quadratic. So negative a over x minus h and then plus k. You could also write it this way with your negative a on the outside and then in parentheses have 1 over your x minus h. Okay, this is helpful if you have a fraction. So what are a, negative a, h, and k? Well, you did learn this once before, so let's go over it. So your negative a, sorry it's kind of dark, but this highlighter is still dope. So minus a, we have a and we have minus a. So a is a vertical dilation. Negative a is a reflection over the x-axis. H and k we talked about the other day. H is going to be a horizontal translation. And remember, it moves the opposite direction of which, the way you would think. Oh my gosh, guys. Okay, and then there's k. And k is a vertical translation. Okay, so I was saying it's very similar to like quadratics and absolute value. Really, all functions are very, very similar because all of these functions, everything that's with x is going to affect x, and everything outside is going to affect y. So that's why h is the only thing that's affecting the x values. It's translating it left or right. A and k, they're not in the parentheses of x, so they're going to affect your y values, reflecting over the x-axis or vertical dilation. You might be asking, well, what about a horizontal dilation? And that's a great question to ask, and the answer is just we don't need them because we can write every single dilation as a vertical dilation. And then same thing with reflection over the y-axis. It actually looks the exact same as a reflection over the x-axis, so we're going to keep things simple. So let's do an example of graphing. So graph k of x equals 3 over x plus 2 and then plus 1. So first thing we want to do is list those transformations. This is required. So vertical dilation by 3. Because 3 is in the numerator. You could also factor it out like I have written up here. 3 is being multiplied. We got 2 translations. We're going to translate left 2 and up 1. And then you should rewrite these as asymptotes. So our asymptotes If it's going left 2, that'll be x equals -2. And it's going up 1, so that'll be y equals +1. So now we can graph it, and if you'd like, you can make a table. So if we make a table, we're going to start with those parent values, which the only ones you really need to worry about are -1, -1, and +1, +1. Those are the turning point values. You could do more if you'd like, it's up to you. But I will only require those for these examples. So because it's vertically dilated by 3, that'll be 3 times y. And then we're going up 1, so it'll be +1. And left 2, so it'll be x minus 2. And then I substitute, so -1 times 3 is -3. -3 plus 1 is -2. 3 times 1 is 3, 3 plus 1 is 4. And the x values, so -1 minus 2, and 1 minus 2. Okay, so now I'm going to make a coordinate plane and graph. So I'm going to go up to 5. I always like to go one higher. Some of you may be asking, like, why even make a table? Tables are nice because, I mean, it shows you how you get your values, and then it also helps you decide how big to make your coordinate plane. So, like, I know I need my y values to go up to 4 and down to -2, and I know I need my x values to go from -3 to -1. It doesn't go to 0 though, so you should always extend it past. We want to see that origin. And if you wanted to make sure you made your graph like the most accurate, then you could add some more points to this. Okay, so now what we want to do is graph our asymptotes. So we've got x equals -2. And y equals 1. And I'm going to plot those points. So -3, -2, and -1, 4. And those are just the turning points. So I know it's going to be going further down and eventually get close to the asymptote. And same thing over here. When you're graphing, make sure you have arrows. Make sure you have your asymptotes. Make sure your asymptotes have arrows. And then make sure it looks like it's flattening towards the asymptote. It doesn't look like it's going to like go through the asymptote. Alright, let's do a graph to equation. Determine the equation of the graph. And I'm going to make you do it algebraically. Which isn't that hard, but just a little bit of work. Okay, so first let's get that graph. So you need to go make a coordinate plane, go up to +3 and down to -6. And then positive 1 should be enough. And negative 8. Cutting it close. Alright, my asymptotes are going to be at negative 5, so x equals negative 5. And at negative 2, y equals negative 2. Alright, and then I want you to plot a point at negative 1, negative 1, positive, oh sorry, negative 3, 0, and negative 4, 2. And then use those to make your curve. See, more points, the more accurate it looks. Okay, and then negative 9, negative 3. Negative 7, negative 4, and negative 6, negative 6. Okay, so pause if you don't have that down. I have to move kind of quick because I'm running out of time. Okay, so you need to first determine the asymptotes. But I labeled them, so that's easy. And then you want to write your equation with your transformation or translations. And A as a placeholder. Substitute a point in and solve for A. We've done this before. And then rewrite your equation. Oh my gosh, my bad. Okay. So, writing our equation, you can write it however you want. Let's call it just f of x. So I'm going to put my a value there, don't know what it is yet. We are going left 5, so it'll be x plus 5. And we're going down 2, so on the outside it'll be minus 2. Okay, so I want to pick a point to substitute in. It could literally be any of these 6 points plotted. I'm going to do the point negative 1, 1. And I'm doing that just because they're lower numbers, easier to work with. So negative 1's the y value. Don't know what a is. Negative 1's the x value. Okay. So because this is on the outside, it's not a part of the fraction, I'm going to move this over. So negative 1 plus 2. And I'm going to simplify my denominator. So negative 1 plus 5. And then to get rid of my 4 in the denominator, I'm going to multiply both sides by 4. So I get 4 equals a. So that means the equation is f of x equals 4 over x plus 5 minus 2. And there's the algebra to prove it.